Today we're going to conclude our discussion of Newton's laws of motion by talking about Newton's first law of motion. And I want you to remember to be taking notes while you watch the video because we'll be using them in class, as well as use those to help you with the Edmodo quiz. So Newton's first law of motion states that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an outside, different or opposite force. So let's break this law down into two parts because it's kind of long. So an object at rest will stay at rest unless acted upon by an outside force. For example, this book sitting on a table will not move from its position unless a force, in this case it's going to be the person's finger, is applied to it, causing the book to move. So you could put a book on a table and walk out of the room and shut the door, and if nobody came in and nobody touched that book for 10 years, you could walk back into the room in 10 years and that book would still be sitting there, as long as nothing else touched that book, causing it to move. You might have, your parents might have some knickknacks on a shelf, like a statue or something, that they put up, a long time ago. As long as nobody touches it, or nothing happens to it that would cause it to shake or move, that object is going to stay there. So in my house I have a bunch of little statues on a shelf, and they're up high, they stay there, they're fine, they never move. But if my kids are jumping around and playing and end up shaking that shelf that they're on, that's what causes my statues to fall over and break. The second part of that law is an object in motion will stay in motion unless acted upon by an outside force. So, we're looking at this book. This book is now sliding across the table from left to right, so it's headed this way, from left to right. The force of friction is acting on the book, and it slows the book down until eventually it will come to a rest. So the book is sliding. If there was no friction, that book would continue to slide forever. If there was no outside forces, no friction, no gravity, nothing acting on the book, that book would just slide forever and ever. Which is why when we did the marbles activity, we did it on the tile floor and not the carpet. Because if we were doing it on the carpet, we would have more friction acting on the marbles, which would slow down the marbles, change the outcome of our results. So here's an example of Newton's first law in action. So sadly, our friend here is not wearing a seatbelt and driving unsafely. So he crashes into the wall and he ends up flipping over the wall. So let's look at this. So the car's moving, crashes into the wall. The car stops moving, but our driver keeps going. You see him again. He flips out of the car and over the wall. And that's because when the car hits the wall is applying a force to the car, stopping its motion. However, the wall is not applying a force to our person. So he is continuing in motion until he is stopped by an outside force. And in this case, the force is gravity and the ground. He's going to collide with the ground. And this is why you should always wear a seatbelt, because when you're wearing a seatbelt in a car and you hit something, I don't know if you've ever felt like moved forward suddenly and had that seatbelt lock. What's happening is the force, when he hits the wall, if he were wearing a seatbelt, the force would then be transferred from the car through the seatbelt onto him, keeping him in the seat. Okay, which is why you always wear a seatbelt in the car, because the car stops, but there's nothing to stop you. There's no seatbelt there. There's no way to transfer that force to the person. You're going to continue to go forward. If you're sitting in the back seat, you're going to smash into the seat ahead of you. If you're sitting in the front seat, you could be ejected out of the car, or definitely hit the windshield or hit the steering wheel really hard. Here's another example of Newton's first law. And so if we look at our skier, we'll catch him on the top of the hill. So he's going to continue in motion until he's acted on by an outside force. So if you look at his speed, right, coming down the hill, his speed is increasing. But then we hit this unpacked snow, which causes friction. And he's also down, he's no longer on a hill, so he's also got gravity really acting on him. And you can see his speed is decreasing. So there's the friction from the unpacked snow and also gravity that's acting on our skier, causing him to stop. So you can see his speed is really high. And once he starts to hit this unpacked snow, you can see his speed decrease because the friction from the unpacked snow. Let's see if we can get these other animations to work. So here we have a motorcyclist. Right, again, he's not wearing, there's no seatbelt or anything. So the motorcycle is being stopped by the outside force, which is the brick wall. And our motorcyclist continues to move until gravity and the ground act on him and stop him. So those are his opposing forces. And here's another example of why it's important to secure things when you're traveling if you put something on your roof. So this truck hits the car exerts a force on the truck causing it to stop. However, clearly this ladder was not hooked down, so the car does not put a force on the ladder. The ladder shoots forward because it continues its motion. So the ladder continues its motion until gravity and the ground are the forces acting on it, which stop it from moving. So make sure you go to Edmodo and do the video quiz now.